Hello, this is Freethought Forum, a program produced and funded by the Atheist Society of Knoxville and by the Rationalists of East Tennessee. I'm Ralph Eisler.
And I'm Larry Rhodes. And we want you to know that if you don't believe in God, you're not alone. Right here in East Tennessee, you can find free-thinking atheists and agnostics. This is a show for them and for people committed to a life rooted in science and free of supernatural beliefs.
Now, this is a call-in show, but we have only one phone line. So if you can't get through, we invite you to tweet to us at FFTVKNOX. And while we go over a few announcements, we invite you to start calling in now at the number on the screen. Get a pen and paper, and we'll give you our email address later in the show.
The Atheist Society of Knoxville frequently has a fun meetup at a bar or eatery here in Knoxville. Tonight's meetup is at Barley's in the Old City, starting around 5:30. We'll all go down there right after the show. Look for the silver-jacketed copy of The God Delusion standing upright on the table. And as Matt Dillahunty of the Atheist Experience, out of Austin, Texas, always says, everyone is welcome to our happy hour for food, drink, and conversation. But if you plan to preach, proselytize, provoke, or punch, please don't.
Okay. Well, the Rationalists of East Tennessee have several regular monthly meetings. First and third Sunday mornings are usually lectures with lively discussions. The book club meets on the second Sunday of the month, and the Reflections group gets together for a potluck lunch on the fourth Sunday. Next Sunday, we're going to watch a recording of a lecture by Dr. Lawrence Krauss, where he discusses the information in his recent book titled A Universe from Nothing, Why There Is Something Rather Than Nothing. He shows how modern science can explain the existence of matter and energy without resorting to the excuse that a supernatural being did it all. Visit our websites for additional details, including times and locations.
And as a lead up to the RET meeting, we thought the question of how the universe came into existence might also be a good subject for today's show. Judging from past shows, our viewers probably have a wide set of opinions on the subject, and this will give them an opportunity to express themselves, particularly if they can't make it to the meeting. But before we discuss these points, let's take a look at some of the items in the news.
Yeah, there's one I came across that I just couldn't resist commenting on here. It's a headline that I found that says, people pray at a tree outside St. John's Cathedral in Fresno, California. They say the tree weeps God's tears. It seems that a crepe myrtle next to the church is dripping liquid from it. Parishioner Maria Ibarra says, when you say glory to God in Jesus' name, the tree starts throwing out more water. And Rosemary Navarro informs us that she said a prayer and asked the Lord to give her a miracle sign because she's really, really sick. And I guess this qualifies as the sign for her.
I guess so. On close inspection, arborist John Realhorn agrees that something is falling from the trees in front of St. John's Cathedral, but it isn't water. He says it's honeydew excrement from aphids who suck the sap from the new growth. The excrement gets so heavy in the summer times that it will drip down. Realhorn says he calls it a natural process. He also found another tree dripping across the street and says it can just be attributed to natural processes.
Okay. And like the honeydew rolling off its leaves, clinical therapist Mark McComber says the way people choose to interpret it can also be attributed to nature. He says human beings inherently need hope for things that they can't understand, things that they can't see. McComber says, to Maria Ibarra, was the first one to feel the drops this Wednesday, and whether they are waste or water, she believes they're divine. She refuses to have her faith tested by some know-it-all tree expert. I can tell you, looking at it from a scientific standpoint and a spiritual standpoint, she says, it is the work of God manifesting here on earth. Someone once opined most people lead lives of quiet desperation. You really have to be pretty desperate to believe God's taking time out from running such a large universe to send aphid droppings as a sign of his omnipotence.
Mm-hmm. Just another sign that if you're not scientifically literate, then the world is a completely different place. It's much more superstitious, supernatural, and mystical.
Yeah, the point that Neil deGrasse Tyson makes all the time.
Right. Mm-hmm. There are a couple of freethinker birthdays that we should mention today. The first is Robert Green Ingersoll, who is has been a topic on this show many times. He was born on August 11, 1833. He was a lawyer, Civil War veteran, American political leader, and orator during the golden age of Freethought back in the 1800s. He was noted for his broad range of culture, and his defense of agnosticism. He was actually nicknamed the Great Agnostic. Many of Ingersoll's speeches advocated free thought and humanism, and often poked fun at religious belief. For this, the press often attacked him, but neither of these views nor the negative press could stop his rising popularity. He was a superb orator, and at the height of his fame, audiences would pay up to $1 or more a head to hear him speak, which was a giant sum for his day. In a lecture entitled The Great Infidels, he attacked the Christian doctrine of hell. All the meanness, all the revenge, and all the selfishness, all the cruelty and all the hatred, all the infamy of which is at the heart of man and in which it is capable, grew, blossomed, and bore fruit in this one word, hell. For those of you just becoming interested in free thinking, Ingersoll's speeches and writings are must-read material, and now they are on the internet, available to everybody for free. They're out of copyright.
Yeah, I don't know if you get them on DVD or not. But,
you can even get them a lot of times just spoken. There are many
people who will read them.
Who are reading them for YouTube or for audio broadcasts.
Yeah, so even this fellow who was at his peak back around Civil War times there, he's still very popular today, and a very powerful presence speaking from the stage.
I'd recommend 2 or 3 particular ones. If you're going to start reading Ingersoll, I would start with either The Mistakes of Moses, or Gods, or The Ghosts, all of which are very good reading.
Yeah. Okay, well, for today's program, it's also particularly appropriate to recognize Erwin Schrödinger, one of the founders of quantum mechanics. He was born August 12, 1887, and he, together with Werner Heisenberg and Paul Dirac, changed forever our understanding of the fundamental workings of nature. It would be almost impossible to imagine how we could even address the topic of why there is something rather than nothing without the knowledge and tools provided by a quantum view of nature. So let's go to our main subject. This might get a little technical at points, but please call in and talk to us about it if you need a little more clarification or if you have comments.
So why is there something rather than nothing?
Well, let's see. Let's start off with the fact that it's often been said that this question of why there's something rather than nothing is the fundamental question of philosophy. It's closely related to whether the universe had a beginning. And these questions have been debated among very intelligent philosophers in some form or other for ages. Now, the problem with philosophers is they don't really like to answer questions. Answers put them out of business. So they're happy to just keep the debate going, and it continues today. You can look on the web and you will find arguments detailing why there is something rather than nothing, or why there should be something rather than nothing, why there shouldn't be something, or what have you.
On the other hand, though, priests and theologians aren't quite as smart as philosophers, apparently, because they postulate a priori that the answer to all is an all-powerful supernatural entity, something like a superhuman being, creating the universe and everything in it at some point in time in the past. There's no evidence for this super being, so theists spend much of their time trying to concoct evidence for its existence in order to show up their postulated beliefs. These two approaches have continued for millennia without making any progress. But some new guys on the block have injected a lot more vigor into the debate in the last few decades. These are the cosmologists. Now, those guys that put makeup on people?
Well, some people might say they do make things up.
Oh,
but
okay. Well, cosmeticians, that's what I'm thinking. Okay.
Yeah, no, you're thinking, yeah. Anyhow, this is very new adventure for physicists. When I was in graduate school in the late 50s and early 60s, it would have been impossible to find a professor who would take a graduate student to do a thesis in cosmology, that is, on how the universe came into existence and how it evolved. mainly because it was impossible to gather detailed data much about the past history of the universe or even very much about its present state. At that time, there were two camps regarding the origin and history of the universe. One camp held that it was steady state, had always existed, and the other held that it had a beginning based on the observed fact that it was expanding. And one of the supporters of the steady state hypothesis, Fred Hoyle, even coined the expression, somewhat derisively, as the Big Bang, as a pejorative
kind of a
expression,
put down,
for the
other side.
People who believed that it had a beginning. Anyhow, all this changed in 1964 when the cosmic microwave background was discovered as a cold remnant of an unbelievably hot initial stage almost 14 billion years ago. The term Big Bang stuck, however, as its description of the initial event.
Wasn't Einstein one of the people who were supporting the static universe?
Before Einstein published his paper in 1916 on general relativity, almost everybody believed the universe was eternal, that it was static. And in fact, Einstein famously put in that constant in his equations that could make it static, because when he had originally formulated them without that so-called cosmological constant, they had no steady state solution.
Right, and he called that later.
He called it later one of his biggest mistakes, and that's after, in 1929, it's about 13 years later, that Edwin Hubble announced that the universe was expanding.
And that's the thing about science. If they find that they're wrong, they say that they're wrong and they move on, because it's the only way that you're going to learn anything. Unlike religion, if they find that they're wrong, they can't really change your mind because the book says it's right.
Yeah.
And the book doesn't change, so you can't change it.
Yeah.
So you've got a problem. Okay. In the succeeding 50 years of cosmology has been developed into quite a precise field of investigation, because scientists have an outlook different from those of philosophers or theologians. They really want to understand how nature works and to find answers to questions. As more and more is learned, these physicists have a great progress in understanding the origin and evolution of the universe. There are quite a few different theological frameworks that have been considered.
Theoretical frameworks.
Okay. Yes. And they all point to the distinct possibility that our universe has come to exist without the need to invoke some supernatural intelligence to create it. As we go along, we'll explain why cosmologists have come to this conclusion.
Looks like we have a call here.
Okay. Well, welcome to Freethought Forum. May we have a name or a nickname, please?
Hey, this is Faithless Forrest. As always, I'm watching the show.
Hello, Faithless.
Hello. You guys were talking about something that it just makes me squirm. I can't stay quiet about it. You were talking about Einstein referring to the cosmological constant. And Larry, you described him as saying he called that his biggest mistake, right?
Yes.
And so I guess I want Ralph to kind of think about this as well. To call it his greatest mistake, I think we got to put into context what would mistake mean. What he realized is that it was real important. Where it was a mistake was for him to not have said, hey, I had to put this term in here, or the universe isn't stable. Why don't you guys go out and check to see if it is stable?
Universe isn't static. It's pretty stable.
Because at the time, we're talking about 1916, and Hubble didn't discover this expansion of the universe until, as I said, about 13 years later, when the Hale 100-inch telescope came online. People just couldn't arbitrarily go out and find the universe was expanding because the instruments weren't there to do it.
I understand, but the point being is that what made it a mistake, I think, from his point of view, is not that he put a fudge factor in, is that he had to put a fudge factor in, and he didn't make a big deal about it and say, hey, I had to do something here that should probably be checked.
Well, yeah.
Well, no, the equations allowed that constant factor to go in. It's cosmological constant.
If the universe was static.
Yeah, I mean, there was
everybody
nothing,
assumed.
There was nothing in his theory that disallowed having that there. And when he realized that his equations had no steady-state solutions, he just put it in.
Well,
And I think that's my point, is that what he would feel in hindsight was a mistake was the realization that if he hadn't just put it in, or if he put it in and made a fuss about it, that would have been, in a sense, to discover the possibility of an expanding or contracting.
Well,
And
I think
I've never read his paper, so I don't know that.
but he didn't really have the tools to discover that yet.
no, and
True.
he actually referred to it as his biggest blunder.
There we go. Yes.
When he refers to something as his biggest blunder, it wasn't necessarily putting that cosmological constant in the equations. It was for not realizing that the universe was not necessarily steady
Right.
state.
He was
Okay, Ralph,
he was
you just
assuming that it
confirmed
was.
exactly what I was asserting.
Well, very good.
Is that
You weren't
that's
so clear on it,
mistake.
Faithless.
Yeah. Well, and the point I want to make is that the issue of whether or not we can have the technology to determine it is independent of the fact that he had the opportunity to have uncovered a question, and maybe we don't know how to determine the answer yet, but he could have proposed that, hey, this says it could expand or this could
Or
contract.
he could have proposed two theories and said, one, if this is a steady state universe, and this if it's not, that kind of thing.
Well,
And
he,
he pointed out that he had to fine-tune it in order to make it stable.
well, he wasn't the person who first solved his own equations. You have to realize Alexander Friedman and Willem de Sitter were the ones who really came up with the solutions.
All righty. Well, so the point being is that it wasn't a mistake, is that it was actually a great insight. Or it wasn't a blunder, it was a great insight.
He called it a blunder. I'm not calling it a blunder. I mean,
And I'm here to contradict him as well. If he were here, I'd say, Albert, please don't call it a blunder. Except if only you mean that you didn't make a big fuss about it at the time.
Okay.
All right. Hey, I will free up the line and hear more about something from nothing.
Okay. Thanks for calling.
yeah.
As we were talking about, as we go along, we'll explain why cosmologists have come to the conclusion that it is an expanding universe. Several books suitable for the average reader have been published on this subject in the last few years. Among these are The Grand Design by Stephen Hawking, and Stephen Hawking and Leonard Mladenov. The Comprehensible Cosmos, maybe I should let you read them, and by Victor Stenger, and most recently, A Universe from Nothing by Lawrence Krauss.
Yeah. Okay, just briefly, we have to explain what the current paradigm is for the evolution of the universe before we start talking about getting something from nothing. And the standard paradigm right now is called the inflationary Big Bang model. It was first proposed by Alan Guth around 1980. At that time, there were problems with explaining observations based on the current expansion rate, which we measure. This was assumed to be in effect since the time of the so-called Big Bang. The cosmic microwave background looked too uniform. It wasn't clear how small variations in density that allowed galaxies to form could be explained, and the flat geometry of the universe could not be readily explained. Now, I'll have to explain what flat geometry means because it too will be important a little later on. Flat geometry doesn't mean that space is two-dimensional like a sheet. Mm-hmm. It means that if you could draw a huge triangle out in space, really light years and light years across, that the sum of those interior angles would add up to 180 degrees, just as if you were to draw it on a flat piece of paper. And like you learned in Euclidean geometry in school or somewhere, that those interior angles have to add up to 180 degrees. But if space is curved, they don't have to. If space is curved positively like a sphere or negatively like a Pringle, they can add up either to more or less than 180 degrees. And this point, as I said, will be quite important in our discussion as it supports the inflationary hypothesis and helps us understand how something can come from nothing.
Around 1980, Alan Guth had the insight to realize that these problems with the standard Big Bang picture could be understood if everything had been much closer in the first fractions of a second, and the initial expansion was driven to be very much faster than the current rate is experienced. This action drove the proportion or portion of the universe that is observable to us today to expand from approximately 10 to the minus 33 centimeters. That's smaller than that, right?
That's much smaller than an atomic nucleus.
In radius at 10 to the minus 35 seconds, which is a billionth of a second.
It's
a billionth of a billionth.
It's a trillionth of a trillionth of a trillionth.
It went from that small size at that small, very beginning time to almost a meter in radius in less than a trillionth of a second.
Right.
Or 10 to the minus 34 seconds. So it was an extremely fast rate of expansion.
Right, and we sort of have shown that on the picture up in the back there. If you look on the left in the diagram, the very left of the line at the bottom shows where Guth would say the universe started, and then that really rapid rise up to the red line is how he thinks it evolved in time.
Kind of like a jump start.
Yeah, like a jump start.
Yeah.
Whereas if you extrapolate that red line all the way back to the left, that's what happens if you extend the present expansion rate back
to
present
zero.
Big Bang, back to zero.
He termed this hypothesis inflation, and it has been shown to explain why CMB, which is
The cosmic microwave background.
okay, the background radiation that is left over from the Big Bang,
Right.
is almost uniform. It also explains that the small deviations from uniformity are a result of quantum fluctuations that became frozen into the space during an inflationary period. Without these differences, the universe could have been totally uniform, with no seeds to allow gravity to produce galaxies or stars.
Okay, well, I think we have another caller here. Hello, caller. You're on Freethought Forum. Could you give us a name or a nickname?
Yes, my name is Al.
Hello, Al.
Hello, Al.
I think one of you guys said, last time you were on here, a couple of days ago, you said something about a guy who read his Bible 48 times.
I thought that was you saying that.
No, I read my Bible 40 times,
Okay.
Well, you don't have the record then.
from Genesis to Revelation in King James Bible.
Have you read any science textbooks?
I've read science,
And when?
geography, history.
When?
Listen, I want to answer your question at the bottom of the screen. My grandson, not too long ago, said to me, he said, Pepe, I was so scared. It came out of nowhere. That was in his bedroom. He lives on another street. And I looked at my grandson. I ain't going to give his name out. And I said, nothing can come out of nowhere. And what you got at the bottom of your screen, something from nothing, nothing can come out of something.
Okay, we're going
it's
into this.
impossible.
We're going
No,
into the
it's-
subject.
Give me an example.
We're going to.
We're going to.
Tell me something that relates to that. Something from nothing.
We're going to talk about this. That's the point of this show. We're going to. It's put up there as a question, and the question is, can you get something from nothing?
All
and
right.
we're going to try
Give
to.
me an example.
We're
well,
going to.
if you'll sit there and watch the show, we will do so.
And you're welcome to call back
And
after we
you
get
call
through
back
that
after
discussion.
we get through
Well,
with the explanation.
Before you throw me off the air, let me read something to you, all right?
Maybe what?
It says, the invisible things of him from the creation of the world are clearly seen, being understood by
The
the
invisible
things that
things are
made.
clearly seen.
Yeah.
Okay.
Even as eternal God, even as
let's-
eternal power and
sorry,
Godhead,
Al.
so that
You
they
can
are
ask-
without
Al, you can talk to us, but you can't preach to us.
And you can't yell over us either.
And you can't yell over us either.
Okay.
So,
Well, without these differences, these tiny fluctuations in the cosmic background, the universe would have been totally uniform with no seeds to allow gravity to produce galaxies or stars. We wouldn't be here. So this is one part of the of something that So this is one part of the something versus nothing question. Quantum fluctuations in the inflation of the early universe are the ingredients for making something. It also explains the flatness of space. You can think of it this way. Suppose you're sitting on the surface of a balloon that's 5 feet in radius. It looks round to you. But now if the balloon suddenly blows up to 5,000 miles in radius, the surface would appear to be flat, just as the surface of the Earth appears to be flat to an individual standing out in the open. Inflation drives the universal geometry to flatness.
Okay, so then let's start to consider this question of why is there something rather than nothing. Even if the answer may be complicated, the question itself looks to be straightforward. But there are several uncertainties and disagreements about different people concerning what it means, even before one tries to answer it. First of all, some people, such as the well-known philosopher Adolf Grünbaum, who describes it as the primordial existential question, the PEQ, he always writes in his papers, says it's not well posed because it assumes nothing is the default condition, when possibly something absolutely has to exist. And this possibility is echoed in a 1980 scientific article by Nobel Prize winner Frank Wilczek, who's noted there is something because nothing is unstable.
Second, the question why implies that the something we experience exists for a purpose. There is simply no reason to believe that. As Nobel Prize winner Steven Weinberg said, the more the universe seems comprehensible, the more it also seems pointless. Today we will interpret why as how does it come about, that there is something rather than nothing. This really is the question that physics can answer.
Okay, and finally, what is meant by nothing? Well, one kind of nothing is empty space with no matter or energy. This is the definition that most people would think of. It's what it's meant to most people throughout human history, and is what most theists are thinking about when they discuss creation. Another type of nothing would be nothing out of which space-time as well as matter and energy can appear, but in which the laws of physics could exist. And a third type of nothing might be that which, out of which not only matter, energy, and space-time can emerge, but also out of which the laws of physics appear concurrently. So there are layers and layers of talking about nothing, and that's why you get into these philosophical discussions that I said that philosophers don't like to solve, and what Krauss complains about, that every time he answers a question about how something can come from nothing, they keep pushing it back and redefining the nothing. Okay, so anyhow, we'll try to discuss how modern physics shows how the universe we observe can emerge spontaneously out of all these types of nothing without the need to postulate any sort of anthropomorphic creator.
So let's talk about the first type of nothing. This would just be empty space. No stars, no planets, no people, etc. The something then consists of all kinds of matter and energy. Now, as opposed to the nothing we're talking about.
Yeah, so this is one way we're going to start here, that we will just say something is all the matter and energy that we can experience and detect in the universe right now.
And this nothing we're talking about here is the total absence of that.
Yes.
No stars, no planets, no people.
No, but there can be space. There can be space. There can be time. There can be laws of physics.
Okay. Now, almost everyone is familiar with Einstein's equation E equals mc squared, which states that mass and energy are equivalent. Because of this relationship, stars can create radiant energy through the fusion process that converts matter to energy, and humans can build atomic bombs. So how much matter and energy is there in the universe if we add it all up? It turns out to be essentially zero. That is, even though we perceive that we are surrounded by lots of something locally, there appears to be nothing on the largest global scale. How can this be? Well, the universe consists of about 5% ordinary matter, about 27% of something called dark matter, whose properties are not really understood to us yet, and 68% of this is dark energy, which acts like a repulsive gravity that's causing the universal expansion to speed up. As we all know, the universe is not only expanding, it's accelerating. Yeah. This is a lot of what we call stuff. But we have to add one more term into the sum of matter and energy, the potential gravitational energy, or gravitational potential energy. This goes into the sum as a negative quantity, but its magnitude is essentially equal to the magnitude of all the other stuff. So although we perceive something locally, we find that when we sum up all the matter and energy terms throughout the universe, the result is zero. And this is what Alan Guth has called the ultimate free lunch. That is, the universe globally generates itself out of nothing. Therefore, the question of how come there's matter and energy rather than nothing is meaningless, because globally the universe consists of nothing. The question then comes, how did our universe arise from empty space?
Right. And so this gets back to answering part of Al's question, that we perceive that there's something in the universe, but globally, when we add it all up, matter and energy, there is nothing in the universe. Locally, obviously, you're here, I'm here,
yeah.
we have automobiles,
But we have
etc.
negative out there to cancel it out.
Yeah, so the gravitational field cancels it out. And so we'll discuss that a little more, but it's about time for a mid-program break here.
Okay. In case you're just tuning in, this is Freethought Forum, a program by the Atheist Society of Knoxville and the Rationalists of East Tennessee. Freethought Forum is funded jointly by them and by individual contributions. Shows are live almost every Tuesday from 5 o'clock to 6 o'clock Eastern on community access television. You can also see it streaming outside of the Knoxville area by going to ctvknox.org.
This is a call-in show, and we're live today. What's this, August the 16th?
13th.
August the 13th. And viewers can call in now to the number on the screen or tweet to us at FFTV KNOX.
The Atheist Society of Knoxville, or ASK, meets 2 times a week. We have evening meetups for fun, food, drink, and conversation. ASK's purpose is to supply a venue for camaraderie, community, and outreach to atheists, agnostics, freethinkers, and other like-minded persons in East Tennessee. Sam, can you run the information videos, please?
If you live in or around the Knoxville area and are questioning your religious beliefs or simply believe in one less God than everyone else, well, you're not alone. The Atheist Society of Knoxville is a fun and friendly group of people just like you that meets twice a week at a bar or restaurant. We meet every Tuesday night following the show at Barley's Tap Room and Pizzeria for happy hour. You'll find our group either inside or on the patio. Look for Richard Dawkins' silver-jacketed book, The God Delusion, standing upright on the table. On Fridays, we meet at Agave Azul or the Beard and Beer Market. But if you plan to preach, proselytize, provoke, or punch, please don't. We all question what we believe at one point in our lives. If this is the time for you, come join us for food, drink, conversation, and fun. Do you find stories of talking snakes laughable? Do you prefer the scientific method over supernatural beliefs? Are you concerned about religious leaders and organizations imposing their values and rules on your body, your family, and the rest of our society? Well, take comfort in the fact that you're not alone. The Rationalists of East Tennessee meets weekly for fellowship and provides a forum for people who support skeptical thinking and rational discussion of these and other issues. To find out more information or to find out about our next meeting, visit us on the web at www.rationalist.org.
Oh, okay, well, the Rationalists of East Tennessee has Sunday activities involving lively presentations and discussion of subjects topical and timeless. And once a month we get together for a book club. You need not have read the book to attend, but of course it helps.
Both the Atheist Society of Knoxville and the Rationalists of East Tennessee help provide a social outlet where if you find that you don't believe in God, you'll also find out that you're not alone.
Okay, well, let's get back to the program then.
Okay.
So we talked a little bit about the fact that if we assume that we have a universe that has space in it, and time, and maybe the laws of physics, on that, and call that the nothing, that we can create out of that all the things we see in the world and in the universe, but it's an illusion that there's something because they all add up to nothing because of the gravity canceling the mass and energy.
Long live the illusion.
Long live the illusion. Yeah. Okay. So going on then, physics tells us that so-called empty space is unstable, that there are pairs of particles such as electrons and positrons popping in and out of it all the time. Since mass and energy are equivalent, Does this violate the conservation of energy? Well, not really. It's possible to violate this principle if the particles exist only for a very short time, as dictated by the so-called uncertainty principle of Heisenberg. An electron-positron pair that just kind of pops out of this empty space lasts for only about 10 to the minus 21 seconds and immediately disappears back in. Now, this isn't just some theoretical conjecture. Even though we can't directly measure these particles, the effects of such events can actually be measured. In fact, the experiments show that some of these measurements on these so-called virtual particles are some of the most precise in physics. They're accurate to about 8 or maybe even 9 significant figures now. This also brings up another point that people don't realize very much, and that's about 95% of the mass of you and me and all the ordinary mass in the universe is due to certain types of virtual particles, not these electrons and positrons that pop in and out of space, but particles called gluons, which hold the quarks in the nucleus together.
Well, right there, I mean, you were talking about virtual particles popping into existence and staying in existence for a very short amount of time. Well, right there is theoretically something from nothing. I mean, and there's no particular reason that those things have to be small.
You can violate conservation of energy for a short time.
Sure.
Hello, caller. You're on Freethought Forum. Do you have a name or a nickname?
I'll go with Brad Pitt.
Brad?
Yep.
Okay, welcome, Brad. Do you have a comment or question?
Well, I've been listening to Mr. Eisler there. It's very, very interesting, and I've been confused by this something from nothing thing.
That's Dr. Eisler.
Oh,
Excuse me.
Mr.'s fine.
Excuse me, Dr. Eisler. But anyway, it seems like when you're describing something from nothing, it's like you're creating a positive and a negative. Is that anywhere near a plausible idea in which to envision it?
Yeah.
Nothing, and then from that nothing, you've got a positive and a negative, and they come together, they annihilate each other.
Let me give you an example, okay?
Okay.
I've got a quarter here I'm holding in my hand, you see, and it's not moving. So its kinetic energy is 0.
Right.
And its potential energy I'm going to define to be 0 where it is. That's arbitrary, and I can do that in a uniform field.
Say it's in free space or something.
Yeah, so it has 0 energy. Now I'm going to drop it into my hand, and just before it hits my hand, it has a velocity, right? So it has positive kinetic energy. But what about its potential energy? It has to be negative, because it started negative, and if we conserve energy, then the potential energy must have gone to a negative quantity, right?
No, I'm not too sure I follow that, but go ahead.
It started at 0, didn't it?
Okay, we started, it has 0 kinetic energy, 0 potential energy. Okay?
Well, when you first started it off, I would think it had more potential energy because it did have the possibility of falling. Or kinetic energy also, I guess you would. Well, potential kinetic energy.
No, potential energy comes from the gravitational field, right?
Okay.
And you have to take my word for it that I can define it as 0 right here. So it has 0 kinetic and 0 potential energy. Just before it hits my hand, it has kinetic energy, which is positive. So in order for energy to be conserved to 0, the potential energy has to be negative right before it hits there, right? Now, I arbitrarily defined that potential energy to be 0 where I had it here. You'll find physics textbooks tell you can do that. But when you're talking about the whole universe, you have to define the potential energy to be 0 at infinite separation.
Okay.
And so what happens is, as the universe starts to expand, okay, if we start with kind of Big Bang picture and the universe starts to expand, and all these particles and dark energy and dark matter appear into it, then the gravitational energy also appears, okay, because we're creating gravitational field. And those cancel each other out. And that's why, as I say, Alan Guth called this the ultimate free lunch. You only have to start with a tiny little bit of matter, which comes from a quantum fluctuation, and you can create a whole universe.
Okay. Well, I I hear what you're saying, and I read Green's book, The Elegant Universe.
Yeah.
And I'm still can understand or even grasp only part of it. But the reason I had the opportunity, I was wanting to take this opportunity to speak with you because in years past there has been this theory with the different dimensions that Green mentions in his book, 11 or so dimensions, and I did not hear, if you're addressing any of this in your something from nothing. So, as in my imagination, I'm imagining these these two brains smacking together and releasing energy or whatever, or that split of nothing, if you will, at that point. And if there's other dimensions, then they apparently do not come into your equation with balancing out the equation to zero.
Well,
they're not considered, apparently.
Well, these other dimensions don't have any mass or energy in them. They're simply dimensions. Now, you talk about two brains smashing together. That's a theory that's called the ekpyrotic theory by Steinhardt and Neil Turok. Paul Steinhardt and Neil Turok.
And brain is short for membrane.
Brain is short for membrane, and this is their alternate theory to the Big Bang. And something that they've been promoting for a few years. We don't know whether it's true. It might be true. In fact, the inflationary theory that we've been talking about, although I say it's been the paradigm for the last 30 years or so, there are people who are starting to think that maybe it's not quite right and are proposing some other ideas. But whatever else is proposed, it's going to turn out to get pretty much the same answer.
Okay. Well, when you're proposing this idea of something from nothing, creating these positives and negatives, if that's a good illusion or illustration, then do we have it happening again? I mean, if I'm in my kitchen making some omelets, and I turn the dial on the stove the wrong way, or
it doesn't
in the wrong combination, I'm not in any danger of creating another Big Bang, something out of nothing in my kitchen, am I? And I certainly haven't heard of anybody
postulating it.
Well, either that or observing. I mean, we've observed supernovas and quasars and all that. Do we observe any of these tiny Big Bang explosions anywhere else where something is created from nothing?
Well, we're going to talk a little bit. I don't know. Did we mention the idea of multiverse?
Not
okay.
Yet.
Actually, we'll get to it. In fact, that was sort of where we were going right now. That Guth's original idea of inflation was found not to explained a lot about things, as we
so
said.
When we have multiverses, now we have infinite nothingness.
Infinite nothingness. No,
well, if you've got different universes and they all add up to nothing, then that would be...
No, I didn't say they all added up to nothing. Yeah, what we don't... what we're talking about currently is our universe, and if these multiverses exist, then they are quite independent of us. We have no connection with them.
Oh, okay.
But presumably, we would have the same problem that you don't need anything really to have them come into creation.
But we're not seeing anything. This is not something that we're noticing out in the Pegasus galaxy or anything like that.
No, they're completely isolated.
All right.
Well,
I appreciate your. I originally was wanting to ask about how the 11 dimensions worked into what you were talking about, and I think you've answered that.
Well,
thank you guys very much, and I'll let somebody else get in here and take advantage of y'all's body of knowledge.
Okay.
Thank you, Brad.
Bye.
Bye-bye.
Yeah. So we'll just go on a little bit, and repeat what we were saying to Brad there. The Goose original models, but modified by several physicists to ameliorate certain problems while retaining the basic idea. And in particular, Andre Linde has shown that the exponential inflation is a continuous process in which now and then bubbles form in the cosmos. And each of these bubbles constitutes a separate universe. That is, reality consists not of a single universe, but of a multiverse in which the individual components don't have contact with each other. And these other bubble universes might be similar to ours, or they might be quite different. So, but the space between these bubbles, in Linde's theory, continues to inflate, producing ever more universes. And moreover, this whole process can be kicked off by a quantum fluctuation that produces no more than 10 micrograms of matter energy to get it started. And although the seed would have a very short lifetime, it would be long enough for inflation to take over and start creating all the mass and energy in the universe. Wow. And this is a mind-boggling theory.
It was for me when I first read it here. We should remark that this multiverse did not begin an infinite time ago. This multiverse had no beginning. The time from any moment in the past to now is finite in our universe, but not in the multiverse. The multiverse would be eternal. It went on forever in the past and will go on forever in the future. It has neither a beginning nor an end. So how can the multiverse have come from nothing? The answer is that since the multiverse always existed, it didn't have to come from anything. Theologians hate this idea because a continually inflating multiverse also continually deflates the uniqueness of special creation of Earth and humans.
Yeah, the Pope really doesn't like this idea very much.
Can imagine.
So, okay, so so far we've been discussing how something can arise out of a background of empty space as one version of nothingness. So where does the space come from? Now, our ideas of space and time are based on the general theory of relativity. This is, next, besides quantum mechanics, one of the two great theories of the 20th century physics. And it was the first theory that could address not only objects moving through space, but also how space itself evolves. But general relativity is a classical theory, so we don't have a complete description of space at the very early times when the universe was extremely small, down to what they call the Planck distance, about 10 to the 45 minus 45 centimeters. And we would need a quantum theory of gravity to enable us to understand in detail how space itself might arise out of nothingness. Nevertheless, enough is known about this question to give us a lot of insight. Task involves a formalism developed by Richard Feynman called sum over paths. It's a formulation of quantum mechanics. It's very powerful and a lot of people like it. And we can't really explain it here. But
well, one thing about Richard Feynman is he lived late enough in the century to have an awful lot of his work on tape. Unlike Einstein, you can't really go back and see him give a lecture, but Richard Feynman you can, and he's got a lot of videos on YouTube. It would be very productive to go see him or listen to him talk.
now,
But this is much too complicated, this sum over paths formalism that we were talking about by Richard Feynman, to discuss here. It implies the possibility that small compact spaces can pop in and out of existence just as particle pairs can pop in and out of empty space. Most of these...
But can I
Sure.
just get in here? That sort of answers a little bit of Brad's question. He doesn't have to worry about it in his kitchen when he changes the knobs on his stove. We're talking about them popping in and out of this background cosmos in which we have all these bubble universes, not out of a particular bubble or a particular universe.
But we do have
aggregation.
virtual particles popping in and out of existence in this universe, don't we?
Oh, yes. Yeah.
That may have been part of his concern. And it wouldn't matter if he was turning a knob on a stove or not. It would just happen all by itself, wouldn't it?
Yeah, sure.
Most of these would not live long, but there's one type of universe that could stay around, namely a compact universe with zero total energy. Now, there is one universe in which the total energy is precisely zero. It is not a flat universe. It is a closed universe in which the density of matter and energy is sufficient for space to close back on itself. In general, such a closed universe would expand to a maximum size and then recollapse quickly to the order of the Planck time, which is about 10 to the minus 44 seconds. But if the fields within such a universe can produce a period of inflation, the universe can be so close to flat that after 100 doubling times, that it could easily last much longer than our universe has been around without collapsing.
Yeah. So even though we don't have a quantum theory of gravity, we know enough about what it would look like to say that quantum gravity not only appears to allow universes to be created from nothing in the absence of space-time, it may require them to do so, because a nothing without space-time is unstable. You would have these things popping in and out. You have some sort of inflationary field that can blow it, up to the size where it can't recollapse. And no external entity is required to set such things in motion. Moreover, the general characteristics of such a universe would be expected to be pretty much exactly what we observe in our universe today.
That's cool.
And so what we've basically said here so far is that there is no physics that prevents these universes from popping in and out of nothing. And in fact, physics seems to indicate that actually they might have to.
That's what's going on, or that needs to go on.
Yeah.
So what about this third type of nothingness that we had discussed that asks whether or not the laws of physics came from, or where they came from? Again, we have to be careful about what this question actually means. Does it mean that somehow there exists specific abstract prescriptions which determine how much matter and energy should interact? In the multiverse, the laws of physics and constants of nature might be different in every universe. They may arise naturally with matter, energy, and space-time without any necessity for pre-existence. But let's just consider our own universe. The physicist Victor Stenger maintains that these laws are simply restrictions physicists place on the models to achieve what he calls a point of view invariance. That is, the description of a physical process should be dependent on how you choose space and time coordinates.
Right. Everything we measure in physics, we pick a coordinate system, and that allows us to put points on a graph and say, well, this car moved from point A to point B. Now, these graphs are imaginary, of course, and if we put our imaginary graph another mile away and say, well, the car moved from point A to point B, it would be a different point on our graph, but it would be exactly the same point on the surface of the Earth, right? So that's what he means by point of view invariance. Or if we looked at some process that proceeded over time, we could start our time just when the process started at t equals 0, or we could start our clock 5 minutes earlier. The process would occur the same way. We would describe it as happening differently in time, but only because of where we put our time coordinate.
How we selected our parameters.
Right, exactly. So that's what he means by point of view invariance.
Okay.
And it has to do with the symmetry of space and time. And in 1915, a young German mathematician named Emmy Noether proved certain mathematical quantities called generators of continuous space-time transformations are conserved when those transformations leave the system invariant. What this means is rotating the coordinate system, imaginary coordinate system, or moving it, or whatever. And the three great classical laws of physics are consequences of these symmetries of space and time. Time translation invariance implies conservation of energy. Space translation invariance implies conservation of momentum. And space rotation invariance implies angular momentum conservation. So we see these three laws of physics require the presence of space-time. They don't exist as independent entities outside of space-time. So you can't say, well, where did they come from? They're inherent in the symmetrical nature of our space. So this idea of point of view invariance can be extended to quantum systems or to explaining the origin of the fundamental forces of nature by invoking what is called gauge invariance. Now, I know we're getting kind of jargony
Technical.
here with the physics talk, but we're almost at the end of the program. And just have to make the point that indeed these laws of physics come about because of these symmetries. And it's fairly straightforward to describe the gauge invariance mathematically, but not so easy to describe them with words. Explaining the three forces other than gravity involves transformation that requires point of view invariance under specific type of rotations. We can't do this for gravity because we lack a quantum theory of this force, but we can do it for the electromagnetic force, for the weak nuclear force, and the strong nuclear force. And if you're really interested in reading this, I recommend Victor Stenger's book, The Comprehensible Cosmos. The bottom line, though, for all of this, if you think you can justify a creator God by saying maybe it didn't create matter, energy, or space-time, but it created the laws that brought them into being, you're out of luck. You don't need a creator God for that either. So we should keep Bob Park's advice in mind. He says at the end of his book, it's called Superstition, Belief in the Age of Science, his last sentence, which got him into a lot of hot water with many people, was that science is the only way of knowing, and that all else is superstition.
Right. And
So-
if I like to always say that if something in religion is proved to be true, it won't be religion doing the proving, it will be science doing the proving.
Yeah, this is one of the funny things. At RET a few weeks back, we played a debate between Victor Stenger and Hugh Ross, who's an old Earth creationist, and Ross was trying to make the point that, well, all these ideas about the expansion of the universe, they're in the Bible. And if you look, when he presented, there's a Bible verse that says, well, the heavens stretch, from horizon to horizon or something like that. It says, see, these people knew about the expansion of the universe.
Right.
Well, if they knew about it, why didn't they tell us, a straightforward way? I mean, it was...
Well, it does us no good if we don't get the idea from what they say that what they mean.
Yeah, I mean, these verses are 3,000 years old, but he's got a crew of people that sits around and goes cherry-picking different verses out of the Bible and just atrociously tries to squeeze them into knowledge that's come out of modern science.
And we're used to saying the road stretches ahead. Does that mean it's literally expanding?
Yeah, exactly. So it's that type of thing, and those are unfortunate. Just like the lady who thinks the tree is weeping tears, and she won't let the tree expert tell her anything else.
Yeah.
I know that there are many people out there who are going to believe that there's a supernatural God who's responsible for all this, and they're just not going to believe anything else if you tell them. Now, one other point about it is you saw we got into this, we didn't get into real nitty-gritty physics details, but even just kind of on this surface that we scratch, it starts to get a little complicated and
non-intuitive.
And non-intuitive, and you have to change your ideas.
Well, it's getting close to time to wrap up things. Get out your pen and paper. This has been Freethought Forum, a program by the Atheist Society of Knoxville and the Rationalists of East Tennessee.
Okay, please send us feedback. You can leave voicemail at 865-272-9060 or email us at freethoughtforum@yahoo.com.
The show's on Tuesdays from 5 o'clock to 6 o'clock Eastern Time in Knoxville, and streaming on ctvknox.org.
So next week, the show, we will be conducting a telephone interview with James A. Lindsay, author of the new book, God Doesn't, We Do. I haven't seen that. I'd be interested.
And on the 27th, Joe and Mary Barnhart will discuss the new born again phenomenon as a naturalistic conversion. I'd like to thank Sam, Jonas, and